Greetings and welcome to lecture number 11 on fluid dynamics. This lecture, we are going to discuss another flow measuring devices, that is notches and weirs. Up till now, we have discussed the flow measuring devices, which are mainly suitable for measuring the flow through pipe. Except pitot tube, it can be used for measuring the velocity through a channel. And later on, we can calculate the discharge. But it generally measures the velocity at one particular point. So velocity may varies with respect to depth as well. So pitot tip is not that much used for measuring the velocity through particular channel, especially the large channels, the narrow channels. So for that, so the device is used that is called as notches and weirs. So in this particular session, we will discuss how to calculate the discharge using these notches. Where are the notches and weirs, and which are the different types of notches and weirs that we are going to discuss. So floor notches, notch is nothing but it may be defined as an opening provided in the side of the tank or vessel, like this opening, such that the liquid surface in the tank is just below the top edge of the opening. The liquid surface in this particular support channel, it must be below the top edge of this particular notch. So this is a triangular notch. So the scale is provided, and we can, if we provide this notch, we can measure the velocity through this particular channel. It's a small channel. This is a practical situation. Notch may be regarded as an orifice with water surface below its upper edge. It is generally made up of metallic plate. It is used for measuring the rate of flow of liquid through a small channel or tank. So for that, it is used. Since it is a small opening. There are, depending upon the shapes, there are different types of notches are also classified. Secondly, where similar to notch, it works on same principle, but it may be defined as a rectangular regular obstruction in an open stream over which the flow takes place. It is made up of masonry or concrete. So like that, these are the or we can say the wear, which are provided especially for measuring the discharge. The conditions of flow in the case of wear are practically the same as that of a rectangular notch. Uh, that is why a notch is sometimes called as wear and vice versa. Wear may be used for measuring the rate of flow of water in the rivers or streams or in dam water also. Uh, that means, in other words, wear is nothing but a larger version of notch. Notches, sometimes it is made up of metallic plates, where they are large size, they are made up of concrete or some masonry structure. So functionally, they both are same. So the terminology is associated with these notches. The sheet of water flowing over the notch, that is generally called as nappe or vein. This is Greek word nappe or vein. So this is a rectangular notch where this sheet of water which is flowing above this uh, bottom edge of the notch is called as a nappe or vein. Or the top of the weir over which the water flows is known as seal or crest. So top of the weir, that is called as a, so this much, this is the water level, then this is called as a seal or crest. So that would be where over which the water flows. So the edge, that is, you can say, uh, over which the water flows, that is called as seal or crest. So these are the two terminologies associated with notch. There are different types of notches and weirs are there. So these are several types of notches depending upon their shapes only. However, the following are the important ones. There are many. So this is a rectangular notch. So that we already studied. So rectangular notch, where the discharge is calculated by measuring this H value, capital H value over the notch. And by putting this H value here in this expression, we can calculate the discharge. So the measurement of H is important. That is, H is measured from the crest to the free liquid surface at the notch, up to the tank level, we can say. So second one is a triangular notch. So where this is H is measured. So the expression of H in this case is cited. The derivation part is not in your syllabus, but in order to calculate this H value, for triangular case, we require a value of theta or the value of H. So sometimes if theta is 90 degree, it is 1.417 H raised to 5 by 2. So, and theta term is missing here actually, which one is nothing but tan theta. So for this is a trapezoidal notch. So trapezoidal notch it mainly consists of the discharge through trapezoidal notch is nothing but the discharge through rectangle notch and one triangular notch, that is right angle triangle notch. So easily we can Q1 plus Q2. This is tan theta by 2, 8 by 15. That one term is missing that I'm telling you. This is directly expression that is CD under root 2G tan theta by 2 H raised to 5 by 2. Theta is known to us. Then we can, so discharge through trapezoidal notch is nothing but the summation of notch through rectangle and triangular notch. So having H is common in this expression. Theta by 2, it may be 90 degree in this particular case, which is 45, 45. And the length is nothing but this length. So trapezoidal notch discharge can be obtained by using this formula. If we split this geometry into rectangle and triangle, and then it becomes the addition of this is rectangle and the two triangles. So two sub triangles, half triangles means full triangle. So that is a rectangle for triangular notch. Step notch. So here in step notch, this is nothing but the addition of discharge of two rectangular notches. So suppose if there are more than three steps, that is Q1 plus Q2 plus Q3. So this is Q1. So for Q1, we can consider, suppose H value this. For Q2, we can consider H value this. L value is B1 is this. So H1, H2. So, sorry, H1 for below it is H2 is considered that the entire, that is free liquid surface. Only H1 we consider here this much. So accordingly, we can convert this strip notch into a multiple rectangle notch, and the addition of all gives us a total discharge to this particular notch. So this is our step notch. So the advantages, but most commonly used, that is triangular and rectangular notches. But the triangular notches are sometimes find it advantageous over a rectangular notch. So that is because for a right angle V notch, or where the expression for the computation of discharge is very simple, because there is only H quantity is required, because for right angle V notch, the expression of Q is 1.417 H raised to 5 by 2. So comparatively, calculation part becomes easy for V notch if it is right angle V notch. A V notch is especially suitable for low discharges. It gives more accurate result than triangular notch, especially for low discharges. For low discharges, triangular notch, sometimes there is error in measurement of H. So under that circumstances, the triangular notch is advantageous, or it gives accurate result. In a given triangular notch, only one reading, that is head H is required to be taken for the measurement of discharge. Yes, theta is almost, once we know the theta, so only one measurement is required, that is H. While in rectangle notch, we have to measure the L also, horizontal distance. Ventilation of triangle notch is not required. The same triangular notch can measure a wide range of flows accurately, even from low discharge to a high discharge. There are some points which differentiate or which are advantages over the rectangular notches. That's it from this particular session. At the end of this particular session, you will be able to describe notches and weirs with their types and expressions of discharges. So even in a practice, you could be able to measure the discharge through these notches as well. Because if you know the expressions, you can calculate easily. So derivation part is not there in your syllabus. Otherwise, the derivation is again similar to the derivations we have obtained for other flow measuring devices. That is by applying the Bernoulli's equation. So that's it from this particular session. Thank you very much.